Hello, everyone. Good morning, good afternoon, good evening, wherever you are passing from to listen and watch this session. Now, today, I want us to basically go through what we call managing a project, managing time on a project, which is basically schedule management, where you can have a system like e-voting, and then you decide to manage the work items within the allocated period of time. So I want us to use a technique called network diagram, that where we can plot our activities. We identify which activity has to start, when is it supposed to start, and which one has to start after the other one has accomplished. Then we also define the time each activity is going to do what to take, by using a technique called network and network diagrams. So now let us I want us to go through together something small here. We can have, for example, activity, and then we can come up with what we call the predecessors. The spelling predecessors, or predecessor actually, then as well as the duration. Now, what do I want to put here? We can identify a few activities that we can use. For example, that we shall carry out activity A, which activity A can be maybe planning. Then maybe it is within this planning that we shall probably identify the requirements, get to know the team that is going to work on on the project, and so on. So now we can also come up with maybe activity B. We can this can be something like maybe analysis of the requirements. Then we can go to activity C, which can be maybe designing of those analyzed requirements. Then we can go to activity D, which can be maybe the implementation, that is if we are to follow the system development life cycle. Then we can also have activity A, which can be testing, and then also activity F. Now, in project management, there is what we call the predecessors. You get. Now, in our table, the table you see, if we have these three columns, where we have the activities, then we are going to have what we call the predecessor. Now, a predecessor means that particular activity that has to first finish before the preceding activity starts. For example, we can say that activity A, since it is always the starting point, has no predecessor. But we are like, for activity B to start, activity A must first finish. So now A becomes the predecessor of activity activity B. So, and we are like, for activity C to start, activity A must have finished. Still, activity A is the predecessor of activity C. And we are like, for activity D to start, activity B must have been accomplished. You get. And then we are like, for activity E to start, we need to first finish activity C. And then for activity F to start, we are like, activity D, we can also put maybe activity E. These two must first finish for this activity to do to start. and we can say like maybe our activity A will last for 5 days. Yeah, so this can be in form of days, in form of weeks, in form of whatever you want to do, what to define, based on how long the project is going to do what to last. If the project is going to last for maybe a month or for a few months, that means it is best you define your duration in terms of weeks or days, you get. Yeah, for proper management. Then we are like, we shall give our activity B a duration of 4 days. Then we shall give activity C a duration of how many days? We can also allocate it to 5. Then activity D, we shall say maybe this will last for 6 days. Then for activity E, our activity E has to last for a period of maybe 3 days, since this is maybe something like maybe implementation, testing, so you don't expect it to be very long. Then for activity E, it can last for maybe for 4 days, depending on what you agree and the complexity or the need of that particular activity. So now, how do we, based on this table, to come up with a network a network diagram? Now, we are going to extract our network diagram based on the activities we have, as well as the predecessors. So in this case, we shall say that maybe we have activity activity A, can have our activity E, but like we said, this one has predecessor. But we are like, for activity B and C to start, you get, for activity B and activity C to start, activity A has to first finish. So meaning that A is done. So we can say here we are going to have, you need to indicate the arrows that shows the flow of accomplishment of a certain activity. So we are like, this is, we can say that for activity B to start, A must finish, and also for C to start, B must A must finish. So meaning that here we have B as well as C. And so since these are done, now we go to activity activity D, and of which D, it is like, for D to start, activity B must be done. So we shall go to B and say, once this is done, then activity D can do can start, the way how you see. For activity D to start, B must be done, the way how you see that B is a predecessor of activity D. So now we can go on and say, we have activity E, and we are like, for E to start, activity C must first finish. So obviously we shall, once our activity C is done, then obviously we can bring in the element of activity E. And we have the last activity, which is F, and we are like, for this activity to start, D and A, which is this one and this one, must do first finish. So we shall have activity activity F, yeah, which has to start immediately after after D and and E. So that is why we now come up with with the F. But this is not this is not allowed. So normally we do we join these. Yeah, we cannot have two ending ending points, as you will see. So we shall go on actually to, we have to go on and plot our we can plot our excuse me, something small. A second, please. Okay. Today, sure you submit the report because the deadline is very good. So before. Okay, that can work. That has no problem. Okay, team. Yeah, now we can go on to plot our durations. We can plot our durations just in this kind of framework where we have activity what? Activity A, that according to our table is going to last for how long? For 5 days. So we shall move in the same way. In the next video, obviously, I will explain to you properly this, but I want to accomplish this by plotting our duration on the activities. So here we are going to have our activity what? Our activity B, which activity B, according to our graph, this one in the second row, lasts for how long? For 4 days. Then we shall obviously go to the next one and say our activity C, according to our table, lasts for also what? How many days? They are also 5. So then we shall go to the preceding one. Don't forget to put arrows on those. Okay. Then we have activity what? Activity D. According to our table, activity D lasted for, it is going to last for 6 days. Then we also have activity E, which activity E is to last for 3 what? 3 days. Then obviously our last one, which is the activity F, but you see that F is lasting for how long? Those are for 4 days. So I want to prepare another, I want to record the short videos, clips for this, so that then in the next one, I show you the critical path, so that you get to know what is the shortest finish time and latest finish time, latest start time, latest finish time of a project. The way how you can see that if you take this route, we have 5 plus 4 plus 6, 5 plus 4, which is 9, plus 6, which is 15, plus 4, which is 19. When you take this root where we have 5 plus 5, 10 plus 3, which is uh, 13 plus 4, which is 17. But we are going to come there, and then you can do what? You can be able to also try it out. But also, I wanted to do it, to do this practically, so that you get to know how to use it also. I think we can first do this practically, though I wanted to first have a draft on paper, then we can go digital to do it practically. Yeah.